we wanted to start a meaningful discussion with the data storage industry. We can see the rapid growth of the unstructured data. The infrastructure that we build to process and store data must be powerful. AI foundation models are a trending topic. There's no AI without sufficient data. We've been investing in data storage industry for more than 21 years. We've compiled a forward-looking data storage industry report based on our experience in the AI age and the capabilities that we have developed to help our customers enhance confidence in the digital future.
In the last episode, we talked about new applications. Big data applications are now in the spotlight, but how does their future development look?
The development of big data applications has gone through three phases: traditional data application, predictive analysis, and proactive decision making. The traditional data area started from 2000 to 2012. Data technology was mainly used to precisely describe historical phenomena. Historical bank details query is one example. The predictive analytics area was from 2012 to 2022. Back then, big data applications would predict what would happen in the future based on the historical statistics. Big data applications are now moving toward proactive decision making to assist real-time, precise, and intelligent decision making.
It is clear that big data applications have become ever more important.
Big data analytics platforms have progressed through three phases accordingly, which are the traditional data warehouse, traditional data lake, and the new lakehouse. Enterprises started to improve IT stacks to get real-time, proactive decision making. This brings big data platforms a step closer to a new lakehouse architecture. Of course, storage vendors also need to get involved to decouple the storage and compute for the big data IT stacks. With data lake storage, the data lakes and warehouses share the same data copy, making real-time proactive decision-making a reality, while data storage keeps up with the trend and leads into the future. Our data storage team and a giant carrier in China works together to research decoupled storage and compute for big data. A data lake storage of over 180 petabytes is built in regional data centers for parallel programs. It provides analytics and processing capabilities for more than 200,000 jobs per day and more than 200 million data records per second. This is huge.
Data lake storage architecture is actually more efficient, as there is no need for data transfer between data lakes and warehouses.
Yes, it supports diverse data access, including multiple data access protocols and different I/O workloads. It has a unified storage pool where data resources or applications in various fields, including data science, AI, and knowledge mining, are integrated. Near-data computing is also supported. This new data paradigm enables big data to better support applications. We can add a high-speed cache between the big data platform and the persistent data storage and make it work as a data acceleration engine. Then, with near-data computing, hundreds of petabytes data query can be shortened from 10 minutes to just 10 seconds, realizing real-time data analytics. So, we advise enterprises to focus on innovative cooperation between big data platforms and storage teams to promote real-time data analysis, set up a team to design joint innovations, and develop a mechanism for regular teamwork.
Really helpful advice. Let's move on to distributed databases. What is their development trend?
Booming digital and mobile technologies have significantly changed the way enterprises and their customers interact. But this comes at a high OM, meaning enterprises choose to rebuild their legacy core systems. Open source distributed databases are now replacing traditional one-core systems. The decoupled storage compute architecture has become the de facto standard for these distributed databases. Stability is the top concern for core databases. Performance, functionality, and energy efficiency are also critical. The decoupled storage compute architecture separates the applications from data for smooth service operation. So, a new data paradigm driven by distributed database is already on the way. We will also see many distributed databases built on the coupled storage compute architecture, but the decoupled one has become the mainstream choice when it comes to the technology, OEM, and the subsequent evolution. In this way, we encourage database and storage teams to work together to build database and core systems. Then, they can fully leverage both of the strategies of the software and hardware to develop a new data paradigm.
Yes, that shows the new data paradigm driven by emerging technologies pushes data infrastructure upgrades and changes the way enterprises choose IT systems.
Yes, another example is multi-cloud deployment, which has become the new normal for enterprise data centers. Container-based cloud-native applications are increasingly used in key services. When deploying multi-cloud architecture, enterprises tend to look for optimal services with low cost and high efficiency. Cloud-native infrastructure is embracing openness and decoupling. Data storage needs to improve resource provisioning. Even more so, data storage needs to be able to serve new cloud-native applications. We encouraged container platform teams and storage teams work together to build container platforms that are agile and highly reliable, and hopefully develop some best practices for containerized applications. We also encourage enterprises to migrate uncertain innovative services along with emerging services like OA to public clouds. These core services can be retained in their on-premise data centers. Meanwhile, the business model of clouds is changing from CapEx-based to OpEx-based. This will reshape the business model of data storage for enterprises. The current industry practice tells us that the coexistence of CapEx and OpEx business models may be the best way out.
That's to say, enterprises can choose the business model that fits their own service needs.
Yes.
Very useful suggestions. Thanks for sharing. Mr. Zhang will give us more insights from other angles in our next video. Stay tuned.
To learn more, you can download our Striding Towards the Intelligent World white paper. Thank you.